So radiocarbon dating, they use this to date, fossils of like plants or animals that used to be living that have died. And they find that radiocarbon dating is less than 1% error for animals or plants that have died within the last 60,000 years. So it's not good for like things that are 1,000,000 years old or something, but if it's less than 60,000 years old, it's pretty accurate. Okay, so we already came up with a half-life formula for carbon-14, and there it is. The first thing we're going to do is we're going to replace that natural log of 0.5 over 5730. We're going to replace this with negative 0.000121. And we talked about that in the last video, but that's going to make it a lot easier for us to write and work with. Okay, so remember the A is representing the amount of carbon-14. I don't know if I should say remember, I don't know that we talked about this, but A is representing the amount of carbon-14 remaining in the artifact, and then A naught, that represents the amount of carbon-14 before it died, the plant or the animal. And what we want to look at, when we have this formula over here, we're dividing by A naught on both sides. We want to look at this ratio, okay? So we want to look at the ratio here. Now they do a good job explaining it in the textbook. I don't know that much about carbon-14 dating. But then we have this A over A naught equaling E, approximately, E to the negative 0.000121t. I should put the approximation in. And that's what R, we're going to replace that ratio with the letter R. Okay, so now we have like kind of a new formula we're saying. Darn it, it's supposed to be an R. R equals approximately E to the negative, let me put approximately, 0.000121t. Okay, now we can solve that equation for t, and that's what we want to do. So, we'll natural log it. So the natural log of R is equal to, it's just going to be that exponent, right? Negative 0.000121t. Okay, so t is going to equal the natural log of R divided by negative 0.000121. Now, this is the formula we're going to use to determine the age of things. So T is going to represent the age of the artifact, or fossil, artifact, whatever we have. And R is going to represent that ratio, and it's going to be given as a percent. So it's the A over A naught, and it's given as a percent of the original carbon-14 in the artifact. Okay, so I'm going to talk a little bit more about you breathe, and carbon-14 is in the atmosphere, and then when the animal or plant dies, then it stops breathing in that carbon-14. So most of the air that we're breathing is not carbon-14, it's carbon-12, but there's a small amount of carbon-14, and so living articles have that in their system, and when they die, it starts to decay, and it's not replaced because they're no longer breathing. Okay, so you can read more about carbon-14 dating, but anyway, so here we go with the problem. We're going to use that formula that I put a box around. I'll just rewrite it. So the age of our fossil is going to be the natural log, and that ratio they're going to give us divided by negative 0.000121. And these are approximately, so, okay. So this is a bone fragment is found that contains 20% of its original carbon-14. So R is going to be, you'll have to change that to a decimal, so it's going to be 0.20. So now we're going to find the age of the bone. It'll be the natural log of 0.20 divided by negative 0.000121. So a couple things to be careful of when we're putting this in our calculator. First of all, you have to make sure you use natural log, and then it's going to open that parenthesis. You're going to put in 0.20, close that parenthesis, make sure you get that second parenthesis in, then divided by, and then you want to make sure it's negative, right? So you use your negative symbol, or you can remember that it's negative, and then just make sure you put in the right number of zeros, 0.000121. And what do we get? It looks like it's about 13301 years old. So our bone is about 13,301 years old. That would be the age of the bone. Okay, bone fragment. All right, so that's how we do radiocarbon dating.